Okay, hello, hello. Okay, so good morning. Today, class, so we are going to discuss common monomial factors. So, good morning, class. So, today, so we're going to discuss our lesson for today is about so, factoring. And the first type of factoring we're going to discuss is none other than the common monomial factors. So what is the common monomial factors? This is our learning objectives for the common monomial factors. So number one, so factor polynomials whose terms have a common monomial factor. Number two, of course, we have to develop tolerance toward individual differences in achieving a common goal. All right, so let's have some refreshing or some recap about before we tackle this lesson. So let's have some review direction. So I want you to find the GCF of the following set. Can you still remember what is GCF? So GCF, look at this one. GCF stands for the greatest common factor. It's the large number that the set of numbers or polynomials have in common. So that is a GCF. And then applying it to our review for today. So this one. So let's try to apply the GCF in my example number A. We have set of 8, 24, and 4. So find the GCF of 8, 24, and 4. Okay, so for us to identify to get the greatest common factor or GCF for those three numbers, we have to identify the prime factorization of each number. So I have this one. Okay, so for the 8, the factors or the prime factors of the 8 is 2 times 2 times 2. In 24, we got 2 times 2 times 3 times 2. Because 2 times 2 times 3 times 2 is 24. And then 2 times 2 times 2 is equals to 8. Next, for the 4, of course, there's a 2 times 2. So those are the factors of each number. And then so for us to identify the GCF, the greatest common factor of the three numbers, just look on the common factor between 8, 24, and 4. So what is the common factor of 8, 24, and 4? That is 2. The common factor between 8 and 24 and 4 is, of course, this one, the 2 here, and there's 2 here. Yeah, so on GCF now, 8, 24, and 4 is 2. Next one. Next one. For letter B, this one, it is a polynomial because it consists of an integer and a variable. So 10y cubed and 15y to the fourth. So first off, okay, so we need to identify the factors of those two polynomials. So there you have it. So look at this. So for the 10y cubed, we got, of course, the factors of 10. Prime factors of 10 is 2 times 5. For the factors of y cubed, we have y times y times y. Okay, then for the next one, the 15y to the fourth, of course, the factors of 15 is 5 times 3. And then the factors of the y to the fourth is y times y times y times y. So, or y. So what is the common or the GCF of the two polynomials? So when we say GCF, it's the greatest common factor. So the common, of course, we have 5 here and 5 over here. And for the y's, how many we have y's? We have, of course, the first y, the second common y, and the third y. So the GCF is 5y cubed because we have 3 y's. So letter C, we have 6 x to the fifth y and Next is 12x to the fourth y squared and 21x cubed y x cubed y cubed. What about this one? So it's the same process, just like letter B. So just get the prime factors of each polynomials. So we have this one. So the first polynomial 6 to the fifth and y. So factors of 6, of course, we have 3 times 2. The factors of x to the fifth power, of course, that is x times x times x times x times x, 5x. And then the factors of y, of course, just y. And then 12 x to the fourth y squared, the factors are, of course, 2 times 2 times 3 times x times x times x times x. And of course, the factors of y squared is y times y. And then lastly, for the 21, the factors of 21, of course, the prime factors is 7 times 3. For the x cubed, we have x times x times x. And for the y, we have y times y and times y. So looking all the factors, okay, it's very long factors. Looking all the factors of each polynomials, the three polynomials. So the common factors, of course, number one is the 3. We have 3 here. We have 3 and 3. Okay. Next, for the x, how many common x do we have? So if we count them all, actually, just look on the least number of x, or least number of the variable x. So since we have 3x here, the answer is of course 3. Let's get the 3x here and another 3x on top. So we have x cubed. Next, for the y, of course, since we have only one y here, so just only one y. So the GCF for this one is 3x cubed and then okay. Next, for the letter D, so for our letter D, 2y times parenthesis x plus 1 and 3 parenthesis x plus 1. So looking at in that example, so it's quite confusing, but it's very easy among those ability the other examples. Take a look. The operation between the 2y and the x plus 1 is multiplication. So when we try to get the factors or prime factors for that particular polynomials, so we have this one. Look at this. For the 2y um, times x plus 1, so that would be, of course, it's a 2y times x plus 1. On the other hand, the 3 times x plus 1, of course, it's 3 times x plus 1. Of course, take a look at the factors. It's very obvious. So the common factors between the two polynomials is, of course, the x plus 1. Yes. So the GCF for this particular example is x plus 1. The whole factor. Okay. So any questions for the example review we have? So let's move on for the next. This one, I want you to give me the product of the following. Letter A, it's 3 times x plus y, and then the other one is x times 2x minus 4y plus 1. So this is just a review. So how do we do this one? Using a number, how do we identify the factor or the product? So this one is, of course, using distributive properties. So just distribute the 3 to the x and y. Okay, so how do we do this one? So just distribute the 8, the first factor. Okay, the first number, the first integer, and then distribute it to the second one, the x plus y. So we got, of course, 3x plus y. Next, we did that number letter B, x times 2x minus 4y plus 1. Of course, let's distribute the x to the 2x and then minus 4y and 1. So we got, of course, 2x squared minus 4x y plus x. Okay, okay, let's have some activity here. So look at the column A and the column B. So I want you to match column A to column B. There is actually a multiplication. So just match the left side column with the right side column. Simple. Okay. Okay, so let's check your answers for this activity. Letter number one. What is your answer? Number one. Of course, we have letter A, correct. Number two, A. Number three, I. Number four, C. Number five, F. Number six, G. Seven, D. Eight, E. Nine, H. And 10 is letter J. So here's the question now. So what are your observations on the expressions in column A compared them with those in B? So do you see any pattern? What are the two expressions related? Why is it important to know the reverse process of multiplication? So it's actually some sort of multiplying. Okay, so if you multiply the two uh, multiplier, okay, on the left side column, you can get easily the product on the column B on the right side column of this activity. So it's very important for us to identify the process, the reverse process of multiplication, for us to easily identify the other factors. Let's say, for example, the only given is the product, but you don't have the factors, you don't have the multipliers. So for you to be able to identify those multipliers, you're going to do the method or process of factor. So how is that? So take a look at this. Okay, with this one. So factoring, okay, factoring is the reverse process of multiplication. So a polynomial is factored completely of each of its factors can no longer be expressed as the product of two other polynomials of lower degree and that coefficients have no common factor. So when we say factoring, again, I just highlight the important term is the reverse process of multiplication. So how is that factoring method? So let's look on this example of factoring. Have some example of factoring with a common monomial factor. So let's have this one. So letter A, 9y to the fourth power minus 15y cubed. So how is that? So so the one that we did a while ago. So first things first, let us identify the greatest common factor of that two polynomials. How is that? So same process. It's like what we did a while ago. So we have, of course, 9y to the fourth and minus negative 15y cubed. So for us to identify the GCF, so let's write it down one by one, just like that. So the factors of the 9y to the fourth, of course, it's 3 times 3 times y times y times y, so that's 4y. So for the 15y cubed, of course, that is 5 times 3, the prime factorization, and y times y, and another y. Next, so what is the common factors between the two polynomials here? So of course, we have 3 on top and another 3 here. And how many y's? So the technique here, just count the least number of y's for the variable. So we have 3 below. So just get the 3 y's up. So the GCF here is 3y cubed. So what is the purpose of the GCF? It's actually So for us to identify the factors of the 9y to the fourth minus negative 15y cubed, the GCF here is our first factor. So look at that. So that will be our first factor. Yes, it's the first factor of our polynomials here. So how do we identify the second factor? So just simply go back to the prime factorization again. This is the first method. Just you can go back to the prime factorization a while ago and remove the 3y cubed on the prime factorization here. Just remove the 1, 3, the first 3, and remove the 3y. So what are the remaining? What are the remaining polynomials? It's actually 3 and y. Right? Next, what about below? 35 times 3 times y times y times y. Just remove again the 3 and the y cubed. Remove the 1, 3. We have 5, and then remove the 3 y's. So the remaining is 5. And there you have it. So the second factor will be is 3y minus 5. And don't forget, because the sign of the 15 is negative, so we put negative here. What about the other methods? What if you don't write the prime factorization? What if you don't have this one, the prime factorization? So how are we supposed to identify the, the second factor using the first factor, which is 3y cubed? If you want to identify the second factor, just simply divide this one. I mean, the given polynomials. Divide the given polynomials to the GCF. So 9y to the fourth power divided by 3y cubed is actually 3y. And then negative 15y cubed divided by 3y cubed is actually negative 5. So that's how you get the second factors. Okay, next example, the letter B. That letter B, it's 6a plus 8a squared b minus 14a cubed b squared. Alright, so what is this? So same process the one we did in the letter A. So first off, we have to identify the GCF of each polynomial. So I just write down, of course, the 6a, of course, is 3 times 2 times a, 3 factors. For the 8a squared b, we have so 2 times 2 times 2 times a times a times b. For the 14, a cube b squared, of course, we have 7 times 2 times a times a times a times b times b. So the common, or the greatest common factor of the three polynomials here, of course, is it's 2a. Alright, so let's put it here. So what is the purpose again of the GCF here? The GCF is your first factor. Right? So the factors of the polynomial, the first factor will be the GCF. So I just write it here. So I just put the parentheses here, meaning to say there's another second factor. So how are we identify the second factor? Of course, first method, you can easily remove. So given the prime factorization of three polynomials, you can easily remove the GCF that you in each factor. So for example, so this one, just remove the 2, just remove the a, the remaining factor is 3. So the 3 is part of the second factor. What about here? Just remove the 2, becomes 7, just remove the 1a. So we have the remainings are 7a squared b squared. That's the second polynomial, the second term. I mean, the third one here, just move the 2 and the 1a, so we have 4ab. And there you have it. That's the second, the second factor. So the factors are 2a times parenthesis 3 plus 4ab minus 7a squared b squared. That's the factor. Alright, next one. The last one. For the letter C. For the letter C, we have 18x to the p power y plus 12x to the 4th y minus 6x cubed y. So same process. So of course, I just write down all the the prime factorization of each polynomials. So there you have it. So for the um, 18x to the fifth y, these are the factors. For the 12x to the fourth y, these are the factors. For the 6x cubed y, these are the factors. So of course, the GCF, the greatest common factor between the three polynomials, between three terms are 6x cubed y. And the 6x cubed y is our first factor. So what is second factor? You can use either cancellation of the factors here or the second one, the division process. So which one is the easiest way? It's up to you. So the second factor will be 3x squared plus 2x minus 1. Alright. Next, so this one is for you. I want you to do this one, application. So this application, I want you to find the factor of each term. It's very easy. Okay. So letter A. Well, let's start to answer. So what is your answer? Number 1. Find the factor of 6x plus 12. What are the factors? It's correct. It's 6 times x plus 2. 6 times x plus 2. Next, number 2. It's 6y squared plus 9y to the power. What are the common factors? Correct. It's 3y squared parenthesis 2 plus 4y cubed. Next, number 3. 8x cubed plus 12x squared minus 16x. So what are the common factors? So the common factors of this is, of course, is 4x. It's the GCF, 4x. Then parenthesis, the second factors are 2x squared plus 3x minus 4. Next, it's very obvious, this one. There's a common factor, of course. The GCF for the common factors is x plus 3. And then the remaining, of course, is x minus 1. So there you have it.